Well, may the flux wars begin. Okay, so recently, by recently I mean like yesterday, I noticed a video from Alex. He made a new blend of flux. Awesome. It's great to hear. I'm glad he's not asleep behind the wheel and finally admitted that and if that flux gums up. Nothing wrong with that per se, and he's right about one thing. It's a triangle, right? So you have three different properties that you can adjust, but you're limited to that triangle, right? So if one angle goes this, then the other angles go like that. So just like, why do we call it a triangle? Because the sum of all angles always add up to 180, right? So you can increase this angle, but you have to reduce other angles, right? So, and if that flux might be gumming up, that's why he made a similar, this isn't his, this is Kingbo, but it's the same formula. I'll show you exactly what components are being used for it and how it works, and I'll mention few properties that were not mentioned in this video, neither mentioned or demonstrated. So we're gonna talk about that for a little while, but primarily the difference between different types of flux is basically manipulating that triangle. So, and if that flux gums up, but it has good heat transfer, and it's essentially potent. And if that white, or whatever he calls it, well, it is white, so yeah, I guess that's very creative of you. It flows better, it cleans easier, and doesn't gum up. Because primarily in flux, you have three things, three ingredients essentially. I mean, a number of ingredients is a lot higher with chemical flux, with synthetic fluxes, but especially with natural flux and pretty much any kind of flux. So you either have rosin or synthetic resin, right? I'll show you under the microscope. So this here on the left, that's synthetic resin. This is what Alex uses and Kingbo and all those Chinese manufacturers. They use this component, right? You can turn it into many kinds of flux. The ones that quickly evaporate, the ones that don't quickly evaporate, the ones that smoke, that don't smoke, and all kinds of things, right? On the right you see natural rosin, right? This comes from trees, right? It's a completely natural component. Now here we see also rosin, right? I bought this as essentially a colophony, right? It's also for soldering, but it's in this form, not in the form of gel, and there's no activator in it, so it's just a rosin. But you see the difference in color, very significant difference in color. That is very important in my batches, right? Because if I see this, I didn't refine it well yet. There's too much contamination. It needs to be this color, like nice amber. That means the flux is going to be good. This means that there's too much contamination. Now, that is not something that you have to worry about with synthetic resin, because you just buy stuff like this, right, made in the lab, and you just mix it with. So this is the active ingredient, right? So you have to mix it with a body, and this could be some kind of a mineral oil or some kind of synthetic oil, something that gives it body, right, the flow. And then optionally you add something like, since Alex said that his flux smells like cardboard, I assume he used cellulose. There are forms of cellulose that you can dissolve in alcohol. That's what causes the flux to kind of turn into jelly. It doesn't really improve any properties of the flux. It just improves the properties of how you apply the flux, how it handles, how it flows before you activate it, right? You don't want it too runny and you don't want it too thick, right? Just so you can squeeze it out of the syringe and it doesn't just flow everywhere before you start heating, right? So you want it relatively thicker when you squeeze it out, and then as soon as you heat it up, all that cellulose burns off of the solution and it becomes more liquidy. So here is the first difference. How do you adjust those two? So if you leave too much of the active ingredient. You're gonna have high potency, but you're gonna have crappy flow, and the flux is gonna gum up. That's why NF.flux is gumming up. Now NF.white or whatever has a little less of this ingredient, or in this case, this ingredient, and a little more body, right? So it doesn't gum up, it's got better flow, but it's not as potent. So the heat transfer is not going to be as great. That's why it doesn't burn, right? If the flux is potent, it's going to burn a lot quicker than when it's thinned out. So I'm not sure about other properties because they were not mentioned. I assume if you make it more runny like that, so NF.white, you need to add more activator, right? Because you want to make it acidic. And here is the difference between the primary difference between synthetic flux and natural flux. It's true that synthetic flux is going to be more consistent batch to batch, but not because of the trees, not because of the reasons that Alex mentioned, but he's right. Synthetic flux is going to be more consistent than natural flux. However, synthetic flux has a very steep angle of activation. Let me just draw it for you guys really quickly. So we have temperature in Celsius, and I should have used something else because here we're gonna have time in seconds. Doesn't matter. So as we increase, and let's say this is our 100 C, right? And here 200 C, right? So the activation of my flux, the natural flux, is gonna look something like this. Activation of synthetic flux is gonna look something like this, right? For that reason, you just kind of work differently with synthetic flux. That's why synthetic flux is great for a manufacturing and stuff where you have to exactly reproduce stuff, right? When you mass produce some boards and every single one needs to be soldered on the same way. So you want to adjust, with the same amount of flux and, in the same temperatures and stuff like that. Now that doesn't mean that 100% of boards they come out of the oven soldered on exactly the same. That's why we have quality control, and from time to time crappy soldering will come out of the oven. But for the same reason, for manual work, like in the repair shop, you kind of want this activation curve as smooth like this, or at least that's what I appreciate in natural flux. So we don't know anything about acidity of NF.white, which is something I would be very interested. Actually, very interested. I didn't purchase it because I just don't really have time, and I know what it's made of, right? I have the ingredients here. I could make some. I was actually even planning to make some, but I had a breakthrough in natural formula. So essentially, I no longer need it. Maybe if I'm bored, I'll play with it. Now the shelf life of synthetic flux is longer. It kind of depends how you make it. Because if you do add chemical components that precisely activate at certain temperatures, and we have that steep change over here, that activation over here can occur over time. So the flux will either start changing color or start changing its texture. Like maybe it'll start producing bubbles, or maybe it'll crystallize, or maybe you'll see some specks in it, stuff like that. In case of my flux, it will over time become thicker, right? Because those ingredients are still reacting with one another. And there's nothing you can do with that. That's what it means, the shelf life. And you might say that the shelf life is 2 years, but the state of the flux is not going to be the same on day 1, day 1 year, and day 2 years, right? If you compare the samples, day it was made, after a year and after 2 years, they're going to be slightly different. So yes, I agree that you would like to have a fresh flux, despite the flux being stable for, well, estimated, say, 24 months. Mine stays usable for up to 24 months. Or at least that is what I guarantee. So if after 24 months your flux is not usable, I'll replace it with a new one, obviously. Not the same batch, obviously. Now, the flow and wetting, these are not necessarily linked to the physical properties. The surface tension, sure, but the flow and wetting, that is directly influenced by the acidity of the flux. And that is really important. That is something that has never been mentioned in Alex's video, this one or the previous ones, regarding acidity. So essentially what you want in flux is that either it is non-corrosive, so if you squeeze it on the board, it's not corrosive, it's not activated, so it's not acidic at all. Then if you increase the temperature to, say, 100 degrees, that's when it becomes acidic. That's when it starts activating. You do your soldering and stuff, and after it cools down, it loses its acidity. That is something that you should expect from Omega 559, especially 559-55 formula. This one is, which one is this? This is 55. So this is 559-55. This one is a little more jellified, right? But very soft, right? Non-sticky. And at this temperature, at room temperature, there should be no acidity. When you heat it up to roughly 100 degrees, that's when the acidity starts. So it becomes more acidic. That is what removes the oxidation layer of whatever you're working on. So that's property number one of flux. Property number two, once that layer has been removed, flux slowly losing its acidity. So it's no longer eating away that layer of oxidation. But property number two is that it covers the area, right? So it's a little oily and it prevents the oxygen from hitting the area you're working on, creating more oxidation, right? So it works in two stages. That's how you use flux. So you squeeze it out, you heat it up, flux eats away all the layer of dirt off the surface you're working on. It stops reacting, right? It deactivates essentially, because all that acidity basically burns off, and prevents new oxidation from building up on that layer. Now, it is true that to a certain extent that you can get the job done with pretty much any flux, any job with any flux, with some exceptions. And now, formula that I had before, that you could see on Tony's channel, testing it, and he even compared like one of my earlier ones with my newest one, and you could see exactly how crappy my first flux was compared to this one. But what I like to do is basically, Alex uses 420 degrees on his iron. Tony uses 330. I use 370. Why so much discrepancy between us? We use different soldering irons. So don't necessarily take the temperature as a exact number that you have to reproduce. You have to see how it flows, right? Because if I increase to 420 my soldering iron, it'll not work great. It'll be overheating the solder. If I drop to 330 like Tony uses, it would not melt anything. Essentially, it would take forever. So 370 to 380 is the temperature that I use. So right now on the soldering iron, I have 370. The tip is 245, right? And it's super dirty, the tip, which I don't really care about, right? So what I like to do, first of all, does it boil? It boils a little, right? Not much, but it boils a little. So first I want to see that my components, my soldering, right, is nice and shiny. What does it mean that it's nice and shiny? It means that the flux removed the layer of oxidation and prevented that layer of oxidation from building when the solder cools down. And what I want to see here, if I heat up this 10K resistor on one side only, right, I want to see it returning to the position, and preferably to the exact position, right, by itself, like this. Right, let's try this one now. And it takes a second to heat up, obviously, right? But there you go. I want to see it just dancing like this, but staying on the pad, right? Not sticking to my iron and none of that. So afterwards, that's usually how I test every new batch, right? Consistency might be slightly different, right? Yours might be a little thicker on one occasion and a little thinner on the other occasion. That's not a difference in ingredients. Ingredients are the same. It's just a matter of precision, right? But let's let it cool down for a second. Have a sip of coffee. And does it gum up? Nope. But it's thick enough. It's kind of like, because there's a lot of it, right? It's very runny. But it cleans very easy. It's non-sticky, right? So that is something that I want to see as well. Obviously, it's a little much for a Q-tip here, because I put way too much of, we didn't need that much flux. But I like to put a little more than a little less, because I want to make sure that the flux definitely covers the entire area I'm working with. Because I don't want that layer of oxidants or oxidation to build up, right? I'm not using any IPA or alcohol or anything, right? I'm just doing dry Q-tip, which means I'm gonna use up quite a few Q-tips, right? But that's what I want to see, that I don't have to use alcohol at this stage. I want to clean it just with dry Q-tip. And what I want to see, you should be able to see it right now, right? You see how shiny the joints are? That's what you want to see. If, on the other hand, the joints are not shiny, one of two things are true. Either you overheated the solder. Now this is, mind you, that this is lead-free solder. This isn't leaded solder. So it's not that easy to make it this shiny. So either you overheated the solder or not enough flux. When the solder was drying, there was access of oxygen from the outside, preventing the solder from being shiny. It just oxidized too quickly while it was drying. So essentially, if the flux can do those two things, right? It flows like you saw it flows, it leaves the joints shiny, and it cleans like this, right, with dry Q-tip. It's a decent flux, right? It should work really well for you. I want to clean a little in between the components, there. And is it sticky, right? It's not sticky, right? It's a little bit of stickiness because it's a natural rosin, right? It's always going to be a little sticky, but it's not a bothering sticky. It's not a kind of sticky that my previous blends had, right? My initial work. They were very, very sticky. Now they clean very easy with alcohol, but in some cases, especially in this case, if you replace this resistor and that one and that one and that one, you want to do some of them, in the row. You don't want to spray alcohol every time because you're cooling down the board, and then you have to reheat the board. So you expose the board to heating cycles. You don't want to do that if you don't have to. But just one spray of alcohol should completely remove the entire leftover flux from here, right? And the joints are nice and shiny. Now we can compare the shininess of the joints to this joint over here, right? This one's not shiny. This one was cooled down without flux. And as you see, those are super shiny, like mirror shiny. So that's essentially what you want from the flux. If it can do that, you know, just focus on the other parameters, other properties. Like in my case, I like the smell of Omega 559. I like that it doesn't contain any toxic components or anything like that. But other than that, it works exactly the same as, almost exactly the same as NF.flux or NF.white. I would say mine is closer to NF.white than NF.flux, but in some cases, you probably want higher potency, right? It kind of depends on what you're working with or what you're working on. So very important to always mention the acidity and acidity curve, right? We don't have that information regarding NF.white or NF.flux. I don't know if anyone actually did any testing regarding acidity, but that I would say is a primary property of flux. It needs to, it's basically an acid that removes oxidants of the material you're working on. Now you can see on YouTube, you can see those shorts where people are showing the difference between the rosin, the flux and paste or whatever, right? And they try to solder on a blob of solder onto, I don't know, aluminum or steel or something like that. Now, these are partially fake because it also greatly depends on the temperature. So if you heat up that metal first, which you can't see in the video, and then apply, you know, magic flux to solder on to the hard material that normally doesn't accept solder, it'll work. In addition, probably they just use highly corrosive acid to achieve that. And in some cases, this is what you need, right? If you want to solder on a big wire onto a pipe or something like that, right? Not only you need aggressive flux, but you also need a lot of it. For microelectronics and small equipment like this, you don't need that much acidity, but you need some. And especially in reballing and stuff, where, because here we can always use the soldering iron to kind of help it out, right? If you start scraping against the pod, you're gonna start scraping off that oxidation layer, and the solder, once it makes it to the points on the board where you scraped it off, it's gonna protect that metal from further oxidation. So you can help the process with, you know, manually with the soldering iron. But in case of reballing, all you can do is just put the flux, put the balls or paste or what have you, and just heat it up. You can't interfere with the process. You can't help it in any way. You just have to rely on the chemistry of the flux to deoxidize the layer and allow the ball to nicely connect with the pod. So this was the major improvement of 559-55. This is what we sell right now. So if you get pretty much any flux that you get from me, you're gonna receive a 559-55. Now, previous one was 559-45, and that 45 and 55, that's not only that's not a batch number. That is actually a number that indicates the formula. So formula slightly different, the difference of 10. I think this one's better, but I may distribute two versions, 45 and 55, depending on the use, right? I think 55 it's pretty good for general soldering and reballing and BGA work in general. Super easy to clean, excellent flow, excellent wetting properties, excellent deoxidation properties, but lower heat transfer, right? It's going to be thinner, so it doesn't burn that quickly, right? As you saw here, right? We didn't even notice the flux getting darker, right? So it doesn't burn that quickly because there's less of this in the formula, right? So the same with Alex's Flux that Mr. White. This crystal, he just put less of this crystal in. That's why it's wider, and that's why it smells. Because if you put more of a body, so more, say, mineral oil or whatever you use, the flux would be too thin. So you have to thicken it up somehow. And as I said, I think since it smells like cardboard, he probably used some variation of cellulose, maybe hydroxyethyl, maybe something else. Doesn't really matter. And that's what turns that oily substance into more of a gel substance, right? But you could just as well not putting it there, and it'll work the same. It's just going to be pain to, because it's going to be running all over the place, right? You like it to be a little jelly, right? A little gel-like or paste-like, because it's easier to apply, essentially. That's the only difference. It doesn't really impact the performance of the flux. So, to summarize, key difference. The angle of activation, I prefer natural flux because of that. Obviously, smell and safetiness, whatever. That's why I prefer natural flux. But downside is that every batch might be slightly different. Not in the way it works, but in the way it feels. With synthetic flux, it's great for manufacturing when you want to maintain super precise proportions of stuff and you want to have consistent results. Other than that, it's a triangle. You can find a sweet spot, but in some cases you're going to need that angle to be larger and this angle to be smaller, which is going to impact this angle, right? The only thing you can do relatively independently is manipulate acidity and activation curve. But in case of synthetic flux, you can't produce a flux that would have a mild activation curve. It's always going to be steep, rapid. As soon as you activate it, it shoots up, right? That's a difference. That's actually a property of rosin itself, because it contains natural acids and they activate slowly. But it's very mild, right? My initial formulas were only relying on the acidity of rosin, but that wasn't enough for the majority of use. Then I started adding activator, and recently I increased the amount of activator that we put in it. So now it should be up to anybody's standards, especially if you work on stuff like this. So in essence, we agree that there's no perfect flux. It kind of depends on your needs, but also, yeah, I agree that you shouldn't compare fluxes as this one's better, this one's not better, right? This one's gooder, this one's badder. Because what does it mean exactly, right? So I would like to focus on acidity, activation curve, wetting, flow, those kind of empirically measured properties that we can empirically measure. Just saying that this one's better, this one's not better, yeah, it doesn't really, you like it more. That's that's pretty much it. I like mine more, although I never used NF fluxes. But I'm glad that we agree on this, and that Alex is improving his formula. It took me almost a year to develop this one, and it's not like I was working alone on it. Plenty of people were doing testing and throwing suggestions. One contributor noteworthy is obviously Tony, not only doing a lot of testing but also submitting suggestions. So it's not like, first of all, it's not like it took a year of 8 hours a day working just on Flux. So obviously, take it with a grain of salt. But it also it takes long because you have to observe what happens to the batch after a month, right? You have to send it to people. You have to wait for people to use it for a while to give you appropriate feedback. what they do like, what they don't like, what it works for, what it doesn't work for, and stuff like that. So it's a lengthy process. So again, I'm glad to hear that he's working on it, because that's what's gonna result in a really good Flux. Actually, I'm glad that he changed his approach, because when Tony said that the Flux gums up, he made a video showing that no, look, it doesn't gum up, right? Now suddenly it does gum up. Well, again, it's the result. It's the learning curve, right? It's not easy to manufacture stuff, and it's not easy to take negative feedback if you're not used to receiving negative feedback, right? If, say, theoretically you're someone who's been, say, on YouTube for say 10 years, and for those 10 years you hear nothing but praises and stuff, and no one really gives you any harsh opinions or anything like that. After 10 years, when you suddenly receive some honest, accurate feedback, yeah, you most likely are going to respond with denial, aggression, retaliation, because you're just not used to that. That's perfectly normal. It's how we grow. None of us is perfect, and none of our fluxes are perfect. Alright guys, so that is Flux demystified. So that's pretty much how it works. Let me just mention, because a few people are asking about the open source formula. Will the Omega 559 be open source? I'm looking into that, but I assure you about one thing. I can, you pretty much know all the ingredients that I use, and that is not where the proprietary formula lies. It's not the ingredients. It's not even the ratio of ingredients. It's the process. The process is it, and it's not even like I can give you the exact times and speeds and stuff. Since I've been doing that for a while now, I rely primarily on looking at the batch, and I know at what point to add another ingredient, right? How long should it mix, at what speed it should mix. Sometimes it's got to be a little higher, sometimes a little lower, right? And I look at, what size of bubbles are forming, or how it flows, how it rises, how it changes color. Based on that, I decide it's time to add another ingredient or stuff like that. So even if I give you all those ingredients and ratios and stuff, you're not going to be able to just reproduce it. And for the same reason, if Alex told me exactly which polymer he's using and what he's using as a body, what he uses as an activator and stuff like that, I also would have to spend probably months, maybe years, to actually reproduce the results. So just a heads up, even if I open source my formula, it doesn't guarantee that you're going to end up having Omega 559 formula that you can make in your garage. And also, on that little note, Alex said something to the effect of it flows better because of the way it is made. It is made in the lab. So, to demystify mine flows just as well because of the way it is made. It is made in the garage. I hope you like it. Some people love it. I'm sure some people hate it and won't order anymore, or maybe even do the return or something. I don't know. But I hope that gives you an overview of what to look for in the Flux and what to focus on. If you have any questions, throw them in the comment. Thank you guys very much for watching. I do appreciate you, and I shall see you guys in the next one.